Welcome to Mathematics Educators Workshop at Home. Today we are looking at the concept of the nature of the roots of quadratic equation. We are going to look at how can we find the nature of the roots of quadratic equation by graphical means. Now, how well can we teach the concept of the nature of the roots of quadratic equation? We are given a graph and its equation. The graph on the right has the equation of f of x is equals to negative x squared minus 2x plus 8. They say consider the graph below and answer the questions that follows. So let us look at the questions. They say determine graphically the value or the values of k for which, question 1, for which negative x squared minus 2x plus 8 is equals to k has no real solutions. Now, when you look at the graph on the right, it is represented algebraically by negative x squared minus 2x plus 8. Now, what does k stand for? We're looking at solutions of this equation. So we're going to break down this equation so we can represent it graphically and be able to determine those solutions. When I look at this equation, it's made up of the following equations. I'm just going to give some names where the other expressions do not have names. So the first one is f of x is equals to negative x squared minus 2x plus 8. So this is the equation of the given parabola. What is the other equation? The other equation is g of x is equals to k. That is the constant line. It's a straight line. It is y is equals to 7, y is equals to 8, y is equals to 100. That is a constant line. That is a horizontal line. So what does it mean? We are looking at the solution of this equation. So we are looking at the point of intersections of these two graphs, the f of x and the g of x. So suppose the value of k is 2. So that graph, it goes like this. So this is the line y is equals to 2. Therefore, there is a solution. These graphs, they intersect here and they intersect there. Now, that means if k is 2, I'll be able to find the value of x at those 2 points. Now, in question A, they say we must find the value of k such that this equation does not have real solutions. So if it does not have real solutions, it simply means that these two lines do not intersect. So if I move this line up all the way above the turning point of this graph, therefore, these two graphs will not meet, and therefore there won't be any solution. But if I move this line downwards, these two lines, they will forever be meeting at specific 2 points that can be found. Now, therefore, the solution for the first question would simply be if the value of k is the number above the turning point. So what is the value of y at the turning point? It is 9. Therefore, if k is a number that is bigger than 9, therefore the value of x, the values this equation has no solution. If k is greater than 9, therefore there is the non-real solution. So there will be non-real solutions if k is greater than 9. The next question says, determine graphically the value or the values of k for which negative x squared minus 2x plus 8 is equals to k has two unequal solutions which differ in signs. There must be two unequal solutions which differs in sign. So that means one of the value of x should be negative and the other one should be positive. That differs in signs. Now let's just draw the line y is equals to k. So like I did before. So if I draw this line, the value of x here is on the negative side. So x here will be less than 0. And the value of x here, it is on the positive side. So x is greater than 0. If I move this line above the value of x here is still positive. If I move up the value of x is positive. If I move it up until the y-intercept, the value of x at this point, it is 0. So if it is 0 and the other one is negative, they still differ in sign because 0 is neither negative nor positive. But what will happen if the line y is equals to k, it is above the y-intercept, but below the turning point. So both the values of x will be negative. So it is when the constant line, it is below the y-intercept of the graph. So what is the value of y at the y-intercept? So the value of y at the y-intercept is 8 from the graph there. The y-intercept here is 8. So there will only be two unequal solutions if the value of k is a number less than 8. For example, k is here. Y is equals to k. When k is a number below 8, this x coordinate here is positive, and this x coordinate here is negative. So for as long as the line, the value of k is a number below 8, therefore this will have unequal solutions which differs with signs. Therefore we simply say k is a number less than 8. So that is our solution. Negative x squared minus 2x plus k, it is equals to 0. It has real and equal solutions. Real and equal solutions. Now, let us look at this. This expression, that is, this equation comprises of expressions that has no relations to the graph that we are given and that we are supposed to use to determine our solution. Therefore, we need to manipulate this equation such that it satisfies the equation of the graph that is presented here on the right hand side. So the first thing we're going to do is we're going to remove this k from this expression because negative x minus 2x, it is part of the expression in the equation of f of x. So we say this is negative x squared minus 2x is equals to negative k. But what can we do to this expression so that it can represent the graph that we are given here? So the missing value here is 8. So we're going to bring 8 to this equation. So this is going to be negative x squared minus 2x. This is equals to negative k. So the number that we are going to bring here, it is 8, so that this expression represents the graph that we have. So we're simply going to bring 8, but then, we're dealing with equation. What do you do on the left hand side? You do it on the right hand side. So we add 8 on both sides. Now, when you look at the equation on the expression on the left hand side, it is the expression that represents the equation of that graph. Therefore, this, we are saying we've got two functions. F of x is equals to negative x squared minus 2x plus 8, and the other graph is h of x is equals to negative k plus 8. Remember, k is a number, so the whole h of x is a constant, is a horizontal line. We are looking for the point of intersection of the two graphs, the graph of h of x and the graph of f of x. So we're saying, what is the value of k such that this equation has real and unequal solution? There must be real and equal solutions. So they can only be equal if they can only be equal at the turning point. Why? Because at the turning point, that is where we have one repeated value of x. If the value of y here, it is 2, the value of x here is negative 3.5, the value of y here is negative 1.5, is positive 1.5. So where is this graph having one solution? It is only at the turning point. Therefore, if the constant line is equal to the value of y at the turning point, therefore there will be one solution. Therefore, the roots will be equal. So let us complete that. Negative k plus 8 is equals to the value of y at the turning point is 9. Therefore, if I take this k on the other side, it becomes positive, and I take the 9 this side, it becomes negative. Negative 9 plus 8 is negative 1. Therefore, we say if k is equals to negative 1, therefore the root of this quadratic equation will be equal. They will be real and equal. Now, we can also prove that by using delta. The next question says negative x squared minus 2x plus k is equals to 0 has real and equal solution. Now, let us look at this equation carefully. This equation does not correctly represent the graph that is represented on the right hand side. But this graph does not necessarily represent, this algebraic equation does not necessarily represent the graph that we are looking at. Therefore, we need to manipulate it so that it can represent the graph that is given to us that we're going to use to determine the solution. So the first thing we're going to do is we're going to remove the value of k. So this is negative x squared minus 2x. This is equals to negative k. So we just take k on the other side of the equal sign. Now we need to find a number that we can put here so that this equation would represent the graph on the right. From our algebraic expression, we can see that the value that is missing there is 8. So we are simply going to add 8 in our equation. So this will be plus 8 and plus 8 on the other side. What you do on the left hand side of the equation, you also do it on the right hand side to maintain the balance. Now, if you look at this expression, it is the algebraic representation of the graph that is given there. Therefore, we cannot be able to deal with our question using the given graph. They say we must determine the value or the values of k such that the roots of this equation will be equal and real. Now, let me just demonstrate the constant line. If we've got our constant line, y is equals to negative k plus 8, moving like that, what is happening is that, let's suppose the value of k at this point is 4. So the value of y here is 4. Now, the coordinate of this point is x and 4. The coordinate of this point is x and 4. But what do you know about x? X here, it is positive, and x here is negative. So these are two values of x that are not equal. Now, what will happen if I now have our constant line passing through the turning point of the graph? At this point, at the turning point, our constant line is equal to the value of y of the turning point. Now, there's only one value of x here, that is -1. So, if that is the case, therefore, this graph will have equal solutions at this point. But if it is any number that is below the value of y of the turning point, our constant line will forever be having two unequal solutions. There will be a value of x this side and a value of x that side. So those values will forever be unequal. Therefore, to solve this problem, we simply take our constant, which is -k plus 8. We simply say -k plus 8, it is equals to 9, which is the value of y of the turning point. Therefore, we can now solve for k. Now, -k is equals to 1. Divide both sides by -1. Therefore, k is equals to -1. So the value of k has to be -1 in order for this equation to have two equal solutions. One other way of doing this is by using delta. So we're just going to use delta to prove that our value of k, it is correct. Now, according to the algebraic definition of the nature of the root, it says if delta, it is equals to 0, therefore the roots of the quadratic equation, they are equal. So we simply write b squared minus 4ac is equals to 0. So this is -2 squared minus 4 times -1 times k is equals to 0. And we solve for k. -2 squared is 4. 4 times -1 is positive. So this is 4k is equals to 0. And we take the 4 on the other side. We've got 4k is equals to -4. We divide both sides by 4. Therefore, k is equals to -1. So the value of k has to be -1 such that the roots of this equation, they are equal and they are real numbers. -x² minus 2x plus k is equal to 0 has non-real solution. So we're going to deal with this like we dealt with question 1a. However, the difference here is our constant line. Like the expression is not different to the expression in question 2b. So this is -x² minus 2x is equals to -k. Therefore, we bring the 8, we add 8 on both sides such that this expression now represents the graph that is given. Determine the value of k, or the value of the values of k, such that the root of this equation will have no real solution, will be non-real. So we said that there will only be non-real if the graphs do not meet. Our constant line, which is the line y, is equals to -k plus 8. If it is below the turning point, they will forever be meeting at any 2 points. But if our constant line is above the turning point, therefore there will be non-real solutions. So we simply say -k plus 8, it is greater than 9. Therefore, this is -k is greater than, this 8 goes that side, we've got 1. We divide both sides by -1, therefore k is less than -1. So if k is a number less than -1, therefore this equation will have no real solutions. Like we did in the previous question, we can also use delta to deal with this. Non-real solution. When does a quadratic equation have no real solution? When delta is negative. So we simply say b squared minus 4ac is less than 0. So this will be negative 2 squared minus 4 times 1 times k is less than 0. So this will give us 4 plus 4k is less than 0. And then we take this 4 that side, we've got 4k is less than 0, is less than 0. When the 4 goes that side, becomes negative 4. And we divide both sides by 4, therefore k is less than negative 1. So k is less than negative 1. Determine the value of k, the value of the values of k for which this equation has real and unequal solutions. They will be real and unequal only if our constant line is less than the value of y at the turning point. So from our previous question, we know that our constant line is the line y is equals to negative k plus 8. So if this line is less than 9, therefore this equation will have unequal solution, real and unequal solution. So this will be negative k plus 8 is less than 9. Therefore, this is negative k is less than 1. Therefore, k is greater than negative 1. When k is a number bigger than negative 1, therefore, this equation will have unequal solutions. There will be real but unequal solution. And we can also prove using delta. If delta is greater than 0, therefore the root will be real and unequal. So if b squared minus 4ac is greater than 0, and we know that this is negative 2 squared minus 4 times negative 1 times k is greater than 0. So this is 4 plus 4k is greater than 0. We take the 4 that side, we've got 4k is greater than negative 4. We divide both sides by 4 and k is greater than negative 1. So if k is greater than negative 1, therefore the root of this equation will be unequal and real. Question 2d. They say negative x squared minus 2x plus k has two unequal negative solution. Two unequal negative solutions. Like we looked at it earlier, we came across a boundary when we were looking for all solutions that two unequal solutions. In question 1b, when we dealt with question 1b, we were looking at two unequal solutions. We said the boundary it is at the y-intercept of this graph, which is 8. If our constant line it is below 8, the root of this equation will therefore be having two unequal solutions, and then being two unequal solution, the other one will be negative and the other one will be positive. Because if you look at question 1b, they said two unequal solutions with which differs in sign. That is why we said we're going to take the value of our constant line to be below 8. Because if it is below 8, whenever they intersect, the other value of x is negative and the other value of x is positive. But what about if our line it is above 8? Now, both the value of x here, this one is negative and this one is negative. Now, that means if the value of our line is a number bigger than 8 but smaller than 9. Therefore, this will have two solutions that are both negative. Now, from our equation, since it is the same as the previous ones, we know that our constant line is the line y is equals to negative k plus 8. Therefore, if negative k plus 8 is a number smaller than 9 but bigger than 8, therefore these two graphs will have unequal solutions which are both negative. So we simply take 8 on both sides. So we've got negative k is less than, when we take 8 that side becomes negative, so that will be less than 1 but greater than, when it comes this side becomes negative and that will be 0. And therefore we divide both sides by negative 1, so that will be k is greater than negative 1 but smaller than 0. So let us look at this and write it correctly in order. K is bigger than negative 1, but smaller than 0. Right. We know that 0 is bigger than negative 1, so the notation is still meaningful, but we can write it using the positive numbers. So I'll write k is less than 0 but greater than negative 1. So both these two notations, they mean exactly the same thing. So if k is a number less than 0 but bigger than negative 1, therefore these two graphs will have two unequal solutions which are both negative. Go on and look at the transformation of functions. Now, with the transformation of functions, like I always say, one of the easier ways is to develop a worksheet that will aid learners' understanding. So I'm going to use the learners' prior knowledge that they acquired in grade 8 and 9 about transformation in order to develop the transformation of algebraic equations for functions. Now, design a worksheet of this nature, give it to the learners as part of the homework. Let them go and deal with the worksheet. When they bring it tomorrow, you do the corrections, and then you take this information, you transfer it to the algebraic functions, and you complete the transformation. So let us look at what is given here. The statement says, consider the point on the Cartesian plane below. Answer the following questions. Question 1, they say, determine the coordinate of point A prime. So we are given point A here. It is negative 2 and 3. All we need to do is to reflect and find the coordinate of A prime according to this reflection statements that are given. 1.1, A is reflected about the x-axis. So that means it is reflected about the line y is equals to 0. So let's look at that. It is negative 2 and 3. When we reflect about the x-axis, so this point, it will go 1, 2, 3 points up from the point of reflection, 1, 2, 3. So the point will be here. So A prime, it is negative 2 and 3. So the coordinate of A prime is negative 2 and 3. So what happened basically, if A is the algebraic expression y, x and y, what will be the A prime algebraically? A prime will therefore be x and negative y. So the only thing that has changed is the value of y, and it has only changed the sign. So basically the rule becomes x and negative y. Let us look at 1.2. A is reflected about the y-axis. So if it is reflected about the y-axis, so this point from point A to the y-axis is 1, 2. So it must move 2 units away, 1, 2. So the point will be at A2 prime will therefore be 2 and negative 3. So the coordinate of A2 prime is 2 and negative 3. So what actually happened is that the point, the value of x changed the sign. So if A was x and y, therefore the rule will be A prime is negative x and y. So when the reflection takes place about the y-axis or the line x is equals to 0, the value of x changes the sign. When it takes place through the line y is equals to 0, the x-axis, the value of y changes the sign. Now, a reflection, when A is reflected about the line y is equals to x. So quickly, let us represent the line y is equals to x. Here is the line y is equals to x. So a reflection about this line, remember, I can simply draw a line through this point that I'm reflecting. That line should be perpendicular to the reflection line. And therefore you check this distance must be equals to the other distance from the reflection point. So the coordinate of point A, 3 prime, will therefore be negative 3 and negative 2. So basically those points, they just swapped around. So the coordinate of A prime in this transformation will therefore be negative 3 and negative 2, of which it came from negative 2 and negative 3. So if the point was x and y, what is the rule? The rule will be A prime is y and x. So the coordinate, they swap around. At question 1.4, we are reflecting the point of A about the line y is equals to negative x. So the line y is equals to negative x is drawn. So you simply draw a line through the point that you are reflecting, going through the line of reflection at right angle. And therefore, what is important is that this distance must be equal to the distance from the reflection line to the image. So when I look at this, the point will lie here. So the coordinate of point A is negative 2 and negative 3. Therefore, the image of A will therefore be 3 and 2. So the coordinate of the image A4 prime will therefore be 3 and 2. This point moved from negative 2 and negative 3. So what happened basically is that this point, they swapped around and they both changed the sign. So if the value, if A generally was x and y, therefore the rule becomes negative y and negative x. So that will be the rule. Now, I also want to demonstrate this point when it is reflected, it is rotated 90 degrees anti-clockwise. Question 1.5, they say determine the coordinate of point A prime when it is rotated 90 degrees anti-clockwise direction. So here is point A. When it is rotated 90 degrees, when A it is rotated 90 degrees anti-clockwise direction. So this is the anti-clockwise direction movement. Therefore, the point land here. So the rotation, it is 90 degrees clockwise fixed at the origin point. So it is rotated 90 degrees about the origin. Therefore, if the coordinate of A were -2 and -3. Now the coordinates are 3 and -2. Now, what actually happened is that the coordinate swapped the coordinate swapped around, but only the value of x changed the sign. So now the coordinate of a 5 prime, this will be 3 and -2. Now what happened is that if a is x and y, therefore the a prime, the rule will be -y and x. Only y changed the sign. Now I just also did the clockwise direction just for the purpose of learning, not according to the worksheet that is given. If the point is to be rotated about the origin 90 degrees clockwise, therefore it will come to this point. So this will be the rotation and the point will land there. It is rotated 90 degrees about the origin. So the coordinate of this point will therefore be -3 and 2. Now please check the coordinates carefully. It was -2 and -3. They swapped the coordinate and therefore only the value of y changed the sign. So if you are rotating 90 degrees clockwise, they swap the positions, but only y changes the sign. So the rule will therefore be, if a is x and y, therefore the rule will be a prime is y and -x. So y and -x. So that is what it is going to be. Now, let us look at question 1.6. The point A is rotated 180 degrees anti-clockwise. Now, 180 degrees anti-clockwise, so this is the rotation above the origin. Now the coordinates were -2 and -3. Now the coordinates are 2 and 3. So basically the coordinates remain the same, but they both change the sign. So the a 6 prime, it is now 2 and 3. So if a was x and y generally, therefore a prime, the rule will be -x and -y. And this, it doesn't matter whether you're rotating anti-clockwise or clockwise direction, the coordinates will be the same. Then lastly, we look at the reflection about a point. We need to reflect point A about point C. So reflecting about a point is not a line. That rule that says draw a line from the point you are reflecting to the line of reflection at right angle to the reflection line, it doesn't apply. We are reflecting about a point. You simply measure the distance from that point. So we are reflecting point A through C. So there is C. Now, how do we deal with this line? I simply look for the horizontal distance and the vertical distance through the point. Now I can see the horizontal distance is 1, 2, 3 units from A to C, and vertical distance is 1, 2 is 2 units up. So I'm going to do the same on the other side. I move 2 units up. It lands me here. And then I move 3 units to the right. 1, 2, 3. So it lands there. So that means the coordinate of the image of point A will lie here. And those coordinates will now be, that is 4, and 1. So these are the coordinates. So if A was -2 and -3, now it is the image of A is 4 and 1. So how do you deal with that? You simply look at the point and find the distance and then reflect a point at a time. This cannot apply as a rule to every point that is being reflected through point C. So I cannot generally write a general rule for every transition about this, because if I had, let's say I had a diagram that goes like this. I've got another point here. They say I must reflect this um, semicircle about the line, about the point C. So every point will have its own transition rules. Like from this point, it is 1, 2, it is 1, 2, 3, 3 units through C. 1, 2, 3, 1, 2, 3. So the other point will be here. And therefore, I just need to find one of the values. Suppose this point here is -3 and 2. So let's suppose this circle was passing through that point, just to make my life easy. So I have to move this point, reflect this point through point C. So this point horizontally it will move 1, 2, 3, 4, and then 1 unit up. So this will be 1 unit up, 1, 2, 3, 4. So the point will be there. So the semicircle will now look like that. So you cannot come up with a general rule for reflection about the point, because each and every point will have to be reflected according to their distance from the point of reflection. So we're given a quadratic function g of x is equals to 1 over 4x squared minus 1 over 2x minus 3 over 4. We need to determine the algebraic reflections of this graph by the following reflection rules. The first one, they say, reflect this graph about the line x is equals to 0, or about the y-axis. So from our work there, we saw that the reflection of a point A, about the y-axis, reflection about the line x is equals to 0, the image takes the rule of the coordinate, the value of x changes the sign. So this becomes -x and y. So that was the reflection about the line x is equals to 0, or the y-axis. So in order for us to do this, you simply go to your algebraic equation and multiply x with -1, because that is the only variable that has changed the sign. So our equation is y is equals to 1 over 4 x squared minus 1 over 4, 1 over 2 so our equation is y is equals to 1 over 4 x squared minus 1 over 2x minus 3 over 4. We are reflecting this graph about the line x is equals to 0. So we simply say x changes the sign. So this is going to be y is equals to 1 over 4 multiply x by -1 minus 1 over 2 multiply x by -1 and minus 3 over 4. And then we simplify the equation. So this becomes 1 over 4 x squared. Negative times negative is positive, 2x minus 3 over 4. So this is the image of the graph of f. So this is g prime of g. It is reflected about the y-axis. Now, let us now go and look at the reflection of this graph about the x-axis, about the line y is equals to 0. The reflection the reflection about the line y is equal to 0. Now, if the point is x and y, being reflected about the line y is equal to 0 or about the x-axis, the image becomes x and negative y. Only the value of y changes the sign. So our equation, it is y is equal to 1 over 4x squared minus 1 over 2x minus 3 over 4. So we simply multiply y by negative 1. So that is negative y is equal to 1 over 4x squared minus 1 over 2x minus 3 over 4. And therefore we make y the subject, we divide every term by negative 1. So this is y is equal to negative 1 over 4 x squared plus 1 over 2x plus 3 over 4. So this will be the equation of this graph being reflected about the y-axis. Sorry, about the x-axis. Now, the reflection about the line y is equals to x. So about the line y is equals to x, we said that the coordinate just swap around. So our equation is y is equals to 1 over 4x squared minus 1 over 2x minus 3 over 4. Now, we do the reflection about the line y is equals to x. It becomes x is equals to 1 over 4 y squared minus 1 over 2y minus 3 over 4. Now, we need to make y the subject of the equation. So from here, I can take the negative 3 over 4 on the other side. So we've got 1 over 4 y squared minus 1 over 2y is equals to x plus 3 over 4. Now, for me to deal with this, I will need to take out the common factor. So I'm going to complete the square. For me to complete the square here, the first thing, the coefficient of x squared is 1 over 4. So I'm going to take it out as a common factor. I'm left with y squared minus 2y is equals to x plus 3 over 4. This is 1 over 4 into y minus 1 squared minus 1 is equals to x plus 3 over 4. I'm going to take the square root both sides. It's y minus 1 is equals to plus or minus the square root of 4x plus 4. So this is y is equals to 1 plus or minus the square root of 4x plus 4. So this will be the equation. Now, obviously, I just used a very large type of an equation, but the grade 11, you are not expected to deal with this according to our curriculum. But this is the scheme. Let's just use a basic question that you will deal with in grade 12. For example, if g of x was y is equals to x squared, that is a parabola. So you will simply swap the coordinate, that will be x is equals to y squared, and you take the square root both sides. Y is equal to plus or minus the square root of x. Hence, we have such kind of expression. So that is the reflection about the line y is equals to x. Now let us look at the last one, which is a reflection about the point. So we've got the point A, which is 1 and 2. You will simply reflect all critical points that define the characteristics of this graph through that point. You identify at least 3, 4, 5, or just enough points that will try and drive the characteristics of this graph. And once you identify them like that, you then reflect them individually through the point that is given. So we are asked to reflect the graph through the point A, which is 2 and 1. So I'm just going to start with C. C, from point C to A, it is 2 units, it is 1 unit to the right and 1 unit up. So from point A, I must move 1 unit to the right and 1 unit up. So the image of C will be here at 2 and 1. That will be the image of C. Now the image of B is -1. So this point, it moves 1, 2, 3. It moves 3 units to the right and 1 unit up. So from point A, I'll move 3 units to the right, 1, 2, 3, and 1 unit up. So that point lies here. So this is the image of B, which is 5 and 2. The image of A, which is it has moved 1, 2, 2 units up and 1 to the right. 1, 2, 2 units up and 1 to the right. So the image of C will be here, which is 1 and -1. Now the other point that we have is point D here, which is 5 and 3. So this point to D, it moves 1, 2, 2 units down, 1, 2, 3, and 3 units to the left. So it's 1, 2, 3, and 1, 2, 2 units down. The point D, the image of D will be here, which is -1 and -1. So the graph will simply go through like that. So this is the graph. This is the reflection of G. This is the reflection of G through the point 1 and 2. Now, colleagues, all these types of questions, you can find them in many of the previous exam material. You will definitely come across this. So let us make use of the average gradient in a function. So the most important thing is stress the definition. The average gradient of a function between any 2 points, it is the gradient of the straight line that is joining the 2 points. These learners, they worked with straight line, gradient of straight line from as early as grade 8. They say determine the average gradient of the graph of f of x. Now f of x is equals to 2 to the exponent x. That is the exponential graph. So this is the graph of f. They want us to find the average gradient of this graph at this point where x is equals to 1, and the other point here where x is equals to 3. So x is equals to 3 at this point. So, but they are saying, if we want the average gradient of this graph between these 2 points, we must just find the gradient of a straight line that is passing through there, which is this blue graph here. So we need to find the gradient of this line. How do we calculate the gradient of a straight line? We say we use the small letter m to represent the gradient, and we say the gradient is equals to change in y over change in x. But what do we know? The only thing we know here is the value of x here is 1 and the value of x here is 2. So this point is called B and that point, sorry, it's called A and that point is called B. So what are the coordinates of point A? The coordinate of point A is 1 and the value of y that we must look for. The value of x here is 3 and the value of y that we must look for. What we know is that this graph here is f of x is equals to 2 to the exponent x. So in order for us to find the value of y here, we need to find the value of f of 1. What is f of 1 is equal to 2 to the exponent 1, so that is 2. What is f of 2? F of 3, which is our second point. F of 3 is equal to 2 to exponent 3, and that is 8. So we know that when x is 1, y is 2. When x is 3, y is 8. Therefore, the coordinate of A, it is 1 and 2 and 3 and 8. And therefore, we can now calculate the gradient. The average gradient is equals to y of b minus y of a divided by x of b minus x of a. Now this is equals to 8 minus 2 over 3 minus 1. So 8 minus 2 is 6, 3 minus 1 is 2, and the answer is 3. 2 into 6 is 3. So the average gradient of this graph between 1 and 3 is 3. Now, algebraically, just like how we found those values of y using the function. So basically, I can write the equation y of b minus y of a divided by x of b minus x of a. This is the same as f of 3 minus f of 2 divided by 3 minus 2. So this is how we calculate the average gradient of a function. Now let us look at this learner exercise. Project this to the learners and let them do it themselves. This was picked from one of the exam material. They say the equation of the parabola below is f of x is equal to 2x squared minus 3x minus 2. Determine the average gradient of the graph between the point B and point C. So the coordinate of C they are given is 1 and negative 3. We therefore need to find the coordinate of B. What is B? Is the x-intercept. So you simply factorize the equation. Let f of x be 0. So that is 2x minus 3x minus 2 is equals to 0. And we factorize. So this is 2x times x will give us 2x squared. So we're therefore looking for the factors that the product that will give us 3. So this will be multiplied by 2, multiplied by 1, negative and positive. So we can see this will be 2x times 2 will give us negative 4x, and then plus 1 will give us negative 3. Therefore, x is equals to negative 1 over 2, or x is equals to 2. So that means the coordinate of B is 2 and 0, because it is right at the x-intercept. So we can simply write that the average gradient is equals to y of b minus y of c divided by x of b minus x of c. Or you can write, this is, the function is f, this is f of 2 minus f of 2 minus f of 1 divided by the value of x there is 2 and this is 1, so divided by 2 minus 1. And what is f of 2? F of 2 is 0 minus f of 1 is negative 3 divided by 2 minus 1 is 1. So this will be 3. So the average gradient of this graph is 3. So this is how we need to deal with this concept before they get to grade 12. Because this concept, they are not taught in grade 12, but they are examinable.